Hello everyone. Today we will be starting with a chapter circles. So first of all, let us see what a circle is. So the basic definition of a circle is the locus of a point which moves in a plane such that its distance from a fixed point in that plane always remains the same. That is known as the circle. That fixed point is known as the center of the circle, and the fixed distance is known as the radius of the circles. So this is a circle. Now let us see the different forms of equation of a circle. So there is this most general form of this, the general form of a circle. The general form of a circle is of the form x square plus y square plus 2gx plus 2fy plus c is equal to 0, where g, f, c are constants. So basically this is a homogeneous equation of degree 2. Now from this equation we can say that the center of the circle is minus g comma minus f. How do we get this? We will see this after we have completed the standard form of the circle. Now, and we can say that the radius of the circle is root g square plus f square minus c. Now, these two will come if we try to complete the square of these terms. Basically, here we have x square plus 2gx, and here we have y square plus 2fy. Suppose here we add g square and f square, and here also we add g square plus f square. So basically we will have x plus g whole square plus y plus f whole square is equal to g square plus f square minus c. So this will form the standard form of the standard equation of a circle, that is x plus h whole square plus y plus k whole square is equal to r square. So basically our center would be minus g comma minus f, and our radius would be root of g square plus f square minus c. Now let us discuss the nature of the circle. If this term, that is g square plus f square minus c, is greater than 0, that is if this term is positive, then that circle would be a real circle. It would be possible to draw it on a plane. If this term comes out to be 0, then that would be basically representing a point. And if this becomes negative, then that would be an imaginary circle, and we say that it is not possible to draw that circle on a plane. Okay, the condition for the general second degree equation to represent a circle. Now, what is the condition for this to represent a circle? The first and foremost condition is a and b should not be equal to 0, where a and b are the coefficients of the degree 2, that is coefficient of x square and coefficient of y square. The second thing being is that they should be equal. They should not be they should not be unlike to each other. They should be equal. Now we have this general homogeneous equation that says ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Now for this, h should be equal to 0, that is the coefficient of xy is 0. Now we have now we see this after comparing this equation with the general form of the circle. The third condition says delta, which is equal to the determinant of this quantity, should not be equal to 0. It implies that the general equation is non-degenerate. That is, equation cannot be written into two linear factors. The fourth condition says that g square plus f square minus c is greater than or equal to 0 to represent a circle. That is, either it will represent a circle or it will represent a point circle. Now comes the standard form of the circle. Now what does the standard form of a circle says? Standard form of the circle is in the form of x square plus y square is equal to a square, where the center for this equation is the origin 0 comma 0, and a is the radius. Now this can also be written as x minus h whole square plus y minus k whole square is equal to a square. Now for that thing, the center of the circle would become h comma k, which is an arbitrary point in the plane in this form. So the equation for this circle is x minus h whole square plus y minus k whole square is equal to r square. Now let us see diametric form of a circle. Diametric form of the circle is of the form x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Now, can you guess how do you get the diametric form of the circle? So basically this is simple. We have read a property in our ninth class that if we draw, if we try to draw and join the points, the diametrically opposite points on the arc of a circle, then wherever on the semicircle arc they meet, they form an angle of 90 degree. So by this property, we say we have taken an arbitrary point x comma y on the arc of the circle, and we have two diametrically opposite points x1 comma y1 and x2 comma y2. So the slope of this line is basically x minus x1 is basically y minus y1 upon x minus x1, and the slope of this line is y minus y2 upon x minus x2. We will multiply this slope as m1 into m2 is equal to minus 1, and after multiplying it we get this form: x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Here we can see the center of the circle is the midpoint of this diametrically opposite point. So we write this as x1 plus x2 by 2 comma y1 plus y2 by 2, and the radius is nothing but the distance between the center and any one of the diametrically opposite points. So this can be written as x2 minus x1 by 2 whole square plus y2 minus y1 by 2 whole square. Okay. Now we see parametric form of a circle. Suppose we have been given a circle whose equation is x square plus y square is equal to r square. Now how its parametric coordinates can be written as: suppose we say the coordinate of the circle is r cos theta and the y coordinate is r sin theta. Now if we put that r cos theta and r sin theta here, so we will see that this equation satisfies. So basically, suppose we have a circle whose center is origin and its x comma y coordinates can be written as r cos theta and r sin theta. So when we write the coordinate as r cos theta and r sin theta, here what we are doing is basically initially we had two variables for the coordinates of a point on a circle. Now after writing this, we have reduced one variable, two variables into a single variable, that is theta. Now r is known to us. Now this coordinate system, this coordinates of the point is only one variable, that is theta. This is basically parametric form of the circle. Now we will compare this by now suppose we'll compare this from a circle whose center is at h comma k. Now suppose its center was at h comma k and we have this equation as this: h x minus h whole square plus y minus k whole square is equal to r square. So what we will do is we will see it as capital X and we will see it as capital Y. And again what we will do is we will replace capital X by r cos theta and we will replace capital Y by r sin theta. So we get small x as h plus r cos theta and we get small y as a k plus r sin theta. So basically we get the parametric coordinates as h plus r cos theta and k plus r sin theta. Now for this case, the center of the circle is whenever we have this equation like this, the general form of the circle Now for this case we know the center is minus g comma minus f. So the perimeter coordinates are minus g plus r cos theta and minus f plus r sin theta, where r is root g square plus f square minus c. Okay. Now let us move to equation of a circle under special conditions. The equation of the circle through 3 points A, x1, y1, B, x2, y2, C, x3, y3 is this determinant. So basically how this determinant comes. So this we will see in the next slides. After we have read the family of circles. Now let us see some illustrations on circles. Now find the equation of the circle which passes through the point of intersection of the lines x minus 4y minus 1 is equal to 0 and 4x plus y minus 21 is equal to 0, and whose center is 2 comma minus 3. Okay, so we have been provided a center and we have been provided two lines whose intersection is a point on the circle. So first of all we will find the point of intersection of these two lines, and the point of intersection comes out to be 5 comma 1. Now since we know the center and a point on a circle, then the distance between these 2 points, point P and the center C, would be the radius of the circle. Now since we know the center of the circle and the radius of the circle, and by the standard equation we can write the equation of the circle, that is x minus 2 whole square plus y plus 3 whole square is equal to radius square, and for this the radius comes out to be 5. So we write this equation as this. Let us see illustration 2. Find the equation of a circle of radius 10. The radius is directly given, whose center lies on x-axis. So the center would be of the form a comma 0 and passes through the point 4 comma 6. So either the circle could be this or the circle could be this. So let us first of all try to write the equation of circle. So the equation of circle would be x minus a whole square plus y square is equal to 100, and we know that the point 4 comma 6 will satisfy this equation. So we substitute 4 comma 6 here. After substituting it here, we get two values of a, 12 or minus 4. So two circles like this are possible, 12 comma 0 and minus 4 comma 0. Find the equation of the circle concentric with the circle x square plus y square plus 4x plus 6y plus 11 and passing through the point 5 comma 4. This again comes down to be a simple question again, because this equation basically gives us the center, that is the center is basically minus 2 comma minus 3, because this term is 2gx. So g is 2 and the center would be minus g comma minus f, so minus 2 comma minus 3. So now we have got the center and we know the point on the circle 5 comma 4. So again we will find the distance between 2 points and we will know the radius. So the radius comes out to be root of 7 square plus root of 7 square, which is equal to 7 root 2. Now since we know the radius, so we can write the equation of the circle as x plus 2 whole square plus y plus 3 whole square is equal to 7 root 2 whole square. basically it is equal to 50. So basically we, after finally opening the squares, we get this equation as this. Now let us see illustration number 4. Find the equation of a circle passing through the origin and making intercepts 4 and 3 on the y and the x-axis respectively. So we see that the circle is making some intercepts on the y-axis and the x-axis as 0, 4 and 3, 0. So what we will do is we'll assume an equation for the circle, and you see that the circle also passes through the origin, and since it is passing through the origin, so these 2 points are the diametrically opposite points. So what we will do is, by the diametrically opposite points equation of the circle, we will write the equation as x minus 3 x minus 0 plus y minus 0 into y minus 4 is equal to 0. So we get the equation of the circle as this. Okay. Now equation of the circle in some special cases. So these are the spaces, these are the cases that we have already discussed earlier. So what are these cases? When the center is 0, 0 and radius is a, so equation is this, when the center is h, plus minus a and the radius is a. So at that point, the equation of the circle is this, depending on what is, if it is h, a, so the equation would be y plus a, and the circle would be here at the uh, and the circle would be here above the x-axis, and else it is, if it is h, minus a, then the circle would be here below the x-axis and it would be touching the x-axis. Now suppose the equation is plus minus a comma k, and the circle would be touching the y-axis, and if it is a comma k, then it would be the right side of the y-axis, and if it is minus a comma k, then it would be in the left side of the y-axis. You should be able to remember these equations if you are willing to solve the questions in a fast way. Now suppose the radius is a and we have the centers of this form. So suppose we have the center a comma a. So the circle would be in the first quadrant and it would be touching both the axes. Now suppose the center is a comma minus a, then the circle would be in the fourth quadrant and it would be touching both the axes. So for this we have these circles and we can write the equation of the circle very simply by the standard form of equation. So we see how standard form of the equation makes our job easy. And what is the standard form of the, and what is the standard equation of the circle? It is basically x minus h whole square plus y minus k whole square is equal to a square, where h comma k is the center of the circle and a is the radius of the circle. When the circle passes through the origin, the center lies on x-axis, and that is radius is a and the center is a comma 0. The equation is this. This is also derived from standard form of circle, so we need not remember this type of equation. We will directly remember the standard form of the circle. We will directly remember the standard equation and we can deduce it from there. Now we have this special case where the center is alpha by 2 comma beta by 2 and the radius is 1 by 2 root alpha square plus beta square. The equation of the circle is x square plus y square minus alpha x minus beta y. So from this we can see that 2gx, g is basically minus alpha by 2. Center would be alpha by 2 and f is minus beta by 2. So minus f is beta by 2. So center would be alpha by 2 comma beta by 2, and radius we can derive from root g square plus f square minus c. So you should be able to see that you do not need to memorize this table. If you are given this equation, then by the use of general form of the circle, you can you can basically derive the center and the radius. And if center or radius is given, then by the standard form you can derive the equation. Okay. Now let us see illustration number 6. So what does illustration number 6 says? Find the equation of the circle which passes through 2 points on the x-axis, which are at a distance 12 from the origin and whose radius is 13. So we are asked to find the equation of a circle, and we have directly been given the radius of the circle, and the circle is passing through 2 points which are on x-axis, which are at a distance of 12. Okay, so there are two circles passing through the point A and A dash. So let us take these points as uh, A and A dash, and basically these points can be a comma 0 and minus a comma 0. Center of these circles lie on y-axis, perpendicular bisector called which is the perpendicular bisector. A dash is the perpendicular bisector of these two circles. So by simple geometry, we can say that 13 square is equal to 12 square plus OC square, where then OC comes out to be 5. So basically y comes out to be 5. So we get x square plus y plus minus 5 whole square is equal to 13 square. So we will get here two equations of the circle. Now let us see position of a point with respect to a circle. Now if CP is less than radius, then the point lies inside the radius. C is the center and point P is any arbitrary point in the plane. Now this is basic. Now this we basically know that if CP is less than radius, the point will obviously lie inside the circle. If CP is equal to radius, then the point will be on the circumference. If CP is greater than radius, then the point P lies outside the circle. Now from these three relations only we can know that if we will try to satisfy the point P in the on the circle, then suppose if the circle's equation is x square plus y square plus 2gx plus 2fy plus c is equal to 0, and if we satisfy that point P, let us say the point is x1 comma y1, and if we satisfy the point P in that equation, then that equation's value would be negative. If the point P lies inside the circle, its circle's value would be 0. If it lies on the circles and the value of the equation would be greater than 0, that is, it would be positive. The circle is if the point is outside the circle. Now power of a point with respect to a circle. Let P x1 comma y1 be a point and a second line which cuts the circle in two points. So PAB is drawn like this. This is a second, and PT is a tangent, and PCD is again a secant. Now what this property says that PA into PB is PC into PT, which is equal to PT square. So what is this? What is the power of the point? The power of the point is nothing but basically when we satisfy the point x1 comma y1 in the circle's equation. Okay. Now let us say the least and greatest distance of a point from a circle. Suppose there is a point P outside the circle. So the least distance would be would be PQ here, and the greatest distance from the circle would be PR here. So what would be PQ? Let S is equal to 0 be a circle and P x1 comma y1 be a point. If the diameter of the circle through P intersects the circle at Q and R, then QP would be mod of PC minus R, which is the least distance, and the maximum distance would be mod of PC plus R, that is the greatest distance. And there are some illustrations, but basically let us first complete the theory of this. Line and a circle. Now suppose there is this line y is equal to mx plus c, and we have this circle x square plus y square is equal to a square. We will basically now satisfy this y coordinate in this. We will get a quadratic equation, and from that quadratic equation we can know the distance between we can know the distance between the between the center and that line. Now if that distance is greater than radius, basically the if that distance is greater than radius, then we say that the line does not touches the circle. That distance is equal to radius, and we say the line is a tangent. And if that distance is less than the tangent, then we say is less than the radius of the circle, then we say the line is a secant. So these are the conditions that you need to remember while deriving these three things. These conditions um, should be made clear in mind, that how they will be used in questions. Now show that the line 3x minus 4y minus c is equal to 0 will meet the circle having center at 2 comma 4 and the radius 5 in real and distinct points if my c belongs to this. Now we have to show this. So how we can show this is, since the line since the line is given and we know the center of the circle, so we can write the distance as distance from the center of the circle to the line. The perpendicular distance is this, and this should be less than radius, that is 6. So on solving this basic equation, we will get that c is minus 4220. Now tangents. So let us see how we can write the equation of tangents in different form. So first form is point form. So what is the point form of the tangent? This is the most basic form. We have been given a point on the circle and we have been said that from this point a tangent is passed. So we have to write the equation of that tangent. So first of all, we know a point from which the line is passing. What other thing we know is, we know the slope of the line. How we know the slope of the line? Because we know the radius is perpendicular the radius is perpendicular to the tangent. So since radius is perpendicular to the tangent, then if we know the center of the circle and we know the point, so from this information we will know the slope of the radius. And if we know the slope of the radius, we know that slope of radius into slope of tangent is equal to -1. So we will also know the slope of tangent. Now if we know the slope of tangent, then we will be easily able to write the equation of this tangent. So basically this is the only thing being done here. The second way is, we directly are able to do capital T is equal to 0. So what is capital T? Capital T is nothing but, suppose we have the equation of circle as x square plus y square is equal to a square. So that equation for capital T is equal to 0 would be, you replace x square by x into x1, replace y square by y into y1, and keep the constant a square as it is. So you will get the equation of the tangent as this: x into x1 plus y into y1 minus a square is equal to 0. Now you will be replacing 2gx. Suppose there comes there also comes x and y. Suppose here comes plus 2gx plus 2fy. Like here they have taken the case of x square plus y square plus 2gx plus 2fy plus c is equal to 0. So in this case, replace x by x plus x1 by 2, and here you will replace y by y plus y1 by 2. So you get x1 plus y1 plus g. This 2 in the denominator gets cancelled by 2 in the numerator. You get g x plus x1 plus f y plus y1 plus c is equal to 0. So basically you have got three ways to find the equation of tangent when you have been given a point. Second is parametric form. So how can you know the tangent when you by the parametric form? Since parametric coordinates of a point on the circle are x square plus y square is equal to a square is a cos theta comma a sin theta, then the equation of the tangent can be, basically again we will write it by x1 plus y1 is equal to a square. So we will write a cos theta x plus a sin theta y is equal to a square. E gets cancelled, one e gets cancelled, so we get x cos theta plus y sin theta is equal to a. Okay. By condition of tangency. So what it is trying to say, let us read it. A line L is equal to 0 touches the circle S is equal to 0. So we have been given a circle and we have been given a line. Now if length of perpendicular P drawn from the center of the circle to the line is equal to radius. If length of perpendicular P drawn from the center of the circle to the line is equal to radius, that is P is equal to R, then this is known as condition of tangency. This we have already seen in the line and circle relation, and we can write the at that time we can write the equation of tangent. Let us see this illustration to clear this condition of tangency. For what value of c will the line y is equal to 2x plus c will be a tangent to the circle? This x square plus y square is equal to 5. So basically what we need is, we need the distance of this line. We need the distance of this line and the center of the circle to be equal to the radius. Here the radius is root 5 and the distance would be this. The distance can be found from here. 2x minus 5 plus c. So the distance would be, since the center is 0 comma 0, so distance would be c by root of 1 plus 4, which is equal to root 5. So c will come out to be root 5 into root 5. So c will come out to be plus minus 5. So the required equation is y is equal to 2x plus minus 5. Okay. Now let us see slope form. The straight line y is equal to mx plus c touches the circle this if c square is equal to a square into 1 plus m square. Therefore, the equation of the tangent is y is equal to mx plus minus a root 1 plus m square, and the point of contact is this. So basically we have been given a line y is equal to mx plus c. So what we are trying to do is, we know the slope of the tangent, and since we know the slope of the tangent, we do not know basically c, that is the intercept. So what we will do is, we will write c in terms of m. How we can write c in terms of m? We will equate the distance of this line and the center of the circle with the radius of the circle. After doing this, we get c square is equal to a square into 1 plus m square. So we write c can be plus minus a root 1 plus m square. By length of the tangent. Suppose the length of the tangent drawn from a point P to the circle S is PT1. So we know the two tangents can be drawn from an outside point P to a circle in this way, PT1 and PT2, and the length of the circle would, and the length of the tangent would be root S1. So what is s? S is the power of the point, and write it as root x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Okay, and this angle between PT1 and PT2 is known as 2 tan inverse r by root s1. This is basic trigonometry and this can be derived. You need not to learn this. Now there is this pair of tangents. What is pair of tangents? So pair of tangents is basically an equation of the form, an equation of 2 degree of the form x square plus y square plus uh, 2gx plus 2fy plus 2hxy plus c is equal to 0. And this equation is basically representing, and this equation basically represent two lines. So how do we obtain this? Basically, first of all, we have circle and we have a point P, and the equation of circle is s equal to 0. That is, s is equal to x square plus y square plus 2gx plus 2fy plus c is equal to 0. And the equation, and we have the point P is equal to x1 comma y1. So the pair of tangents is given as s into s1 is equal to t square. So this came from the s1 is the power of the point, s is the equation of circle, and t is the equation of tangent. This equation of tangent can be written as x1 plus y1 plus gx plus x1 plus y plus f y plus y1 plus c is equal to 0. So from this we get the pair of tangents. So basically we do not have much into it, we just need to learn this formula. See, so question like this comes in JEE-Mains. Find the equation of the pair of tangents drawn to the circle x square plus y square minus 2x plus 4y from the point this. So basically we just have to apply this formula, and this is the previous year question, and we will get the answer. So how we are applying this? We know the equation is s1 would be, we will put this point here in this equation, so we get 1 plus 4y, that is 5, and the tangents equation comes out to be x1 plus y1 minus x plus x1 plus 2 times y plus y1. Y1 is basically 1, x1 is basically 0. So we get x into 0 plus y into 1 minus x plus 2y, 2 into y plus 1. So we get t as minus x plus 3y plus 2, s1 as 5, and s is basically this. So we will square this and we will get the pair of equation of this form. Okay, now let us see what a director circle is. So basically sometimes in JEE they directly ask that a circle is given and please tell us the director equation of the circle. The director circle is nothing but the same circle, but a concentric circle of the circle that is given to us, and the radius is root 2 times the radius of the given circle. Suppose you have been given the circle x square plus y square is equal to r square, and to they ask you to form the director, to give the equation of the director circle of this given circle. So the director circle of this given circle would be x square plus y square is equal to 2r square, because the radius is root 2 times the radius of the given circle. And what is the definition of this director circle is? The director circle's definition says us that the director circle is the locus of the points where the tangents make 90-degree angle with each other, where the pair of tangents make angle of 90 degree with each other. Now there is a property that if a point is inside the director circle and it tries to make tangent on the given circle, then the angle it form would be greater than 90. And if a point is outside the director circle and it makes tangent on the inside circle, the given circle, then the angle of that part of that would be less than 90 degree. So these are some basic rules for director circle. So what it is, we will see an illustration. So the illustration says that find the equation of director circle of the given circle. So please attempt this. Okay. So the circle center is 2 comma minus 1 and the radius is root 2. So we know that the center of the director circle is the same as the center of the given circle. The center would be 2 comma minus 1 and the radius will become root 2 times our radius. So the radius would become root 2 into root 2. So the radius becomes 2. So we get the director circle's equation as x minus 2 whole square plus y plus 1 whole square is equal to 2 square, that is equal to 4. So we get this required equation. So these type of questions also comes into JEE mains. Now let us see what a normal is. The normal of a circle at any point is a straight line perpendicular to the tangent and passing through the center of the circle. Okay, so now since if a now suppose equation of a normal when the point is given. Suppose if the point is given to us, then the question becomes very easy because we know the point from which the line is passing and we know the center. So we directly take out its slope and we then are able to write the equation of the line. Now suppose we are given the circle's equation and we are given the tangent. So tangent's equation. Then what we can do is, you know, the slope of the normal would be minus 1 by the slope of tangent, minus 1 upon slope of tangent, and we know it is passing through the center. So we know the slope and we know the point that it is passing from center, then we can easily write the normal's equation. So this was only what is said here. Now let us see the parametric form. The parametric form says that suppose there is a point a cos theta comma a sin theta on the circle, and we have been given the circle's equation as x square plus y square is equal to a square. Then the normal's equation would be x by a cos theta is equal to y by a sin theta. So how we come to this? How do we come to this equation? Basically, we know that center is 0 comma 0 and slope is a sin theta upon a cos theta. So basically the slope is tan theta. So we equate it by y minus a sin theta upon y minus a cos theta is equal to tan theta. So by doing this, we get this equation. Now let us see what is pole and polar of a circle. Now this is an important topic which is being asked in JEE mains from the past 3 to 4 years. So see, let P x1 comma y1 be any point inside or outside the circle. Passing through the point P, chords AB and A dash B dash are drawn. Okay. If the tangents at point A and point B intersect at Q, then the locus Q is a straight line and is called the polar of point P. Okay. So basically this is a point P, and we draw a secant as this, and we draw another secant as this. So AB is a chord and A dash B dash is another chord. And from AB we draw a pair of tangent, and their point of intersection is Q. And from A dash B dash we draw another pair of tangent, and their point of intersection is Q dash. And the line joining Q and Q dash, that line is known as polar. Similarly, if the tangents to the circle at A dash and B dash meet at Q dash, then the locus of Q dash is the polar with P as its pole. Suppose if P was inside, then also this Q and Q dash lines locus. Basically, this line Q and Q dash would be known as polar. Now let us see the equation of polar of the circle. Suppose we have been given a circle x square plus y square plus 2gx plus 2fy plus c is equal to 0. With respect to point P, x1 comma y1, the polar's equation is x1 plus y1 plus g x plus x1 plus fy plus y1 plus c is equal to 0. So this is basically very easy. If this is nothing but t is equal to 0, this equation is nothing but t is equal to 0, because we know if the point would have been on the circle, if the point would have been on the circle, then this equation would have represented a tangent. But if the point is either outside the circle or inside the circle, then this equation represents polar. So if the circle x square plus y square is equal to a square, this is given, then its polar is x square plus y1 minus a square. That is t is equal to 0. So basically polar is nothing but t is equal to 0, that we have already learned. And if the point comes on the circle, then t is equal to 0 represents tangent. And if the point is outside or inside the circle, then the equation t is equal to 0 represents polar of the circle. So you just need to remember what is t is equal to 0, and it will basically solve 3 of your questions. Now let us see what is a pole of a line with respect to circle this. So suppose we have been given a circle, and we have been given a line, and we are being told that this line is the polar of this circle. So basically we will do nothing. We'll just assume that x1 comma y1 is the pole of the given circle, and we will write the equation t is equal to 0 as polar. So we have written this equation x1 plus y1 plus g x plus x1 plus f y1 y plus y1 plus c is equal to 0. And we will compare these two equations. We will compare the coefficients of these two equations. So on simplification we will get this, and after simplification we will get x1 y1, and we can get x1 and y1, so we can find what is the pole of the circle. So these were some simple questions. Let us take a quick look at this previous year question. Find the pole of the line 3x plus 5y plus 17 is equal to 0 with respect to the circle. So the approach is simple. We will first take x1 comma y1. We will first assume that x1 comma y1 is the pole of the given circle. So we will write x x1 plus y y1 plus 2